Nice to see your background. Noor, you're next.
Hi, I'm Noor. I'm from Turkey. I'm an environmental consultant. I did my master's degree in AA under the program Sustainable Environmental. And now I'm doing environmental consultancy. Yeah.
Super. And then Mohammed.
Hi. Can you hear me?
Yes.
Yes. Nice to meet you. I'm Mohammed. I'm from Iran. Graduated in architecture. I'm being environmental analyst.
Thank you.
Thank you.
Üzge.
Hi. Yeah, it's no problem. I'm Özge from Turkey, like Nur. I'm an architect and urban planner student. Currently, I'm a member of the City Development through Design Intelligence Lab led by Imdatas from Istanbul Technical University. Yeah, that's all.
Thank you.
Yeah,
and Victor?
Hi guys, I'm a Brazilian but currently working in Denmark as a computational design intern and doing my master's in architecture engineering. Glad to be here.
Glad to have you. And Antigone, I think you were here last year as well, right?
No.
No, sorry.
Hi everyone. I'm Antigone. I have an architectural background and I'm working in the UK as a building and physics engineer. That's me.
Thank you. Nora.
Yeah, hi everyone. I'm Nora. I'm Swiss and I have a bachelor in industrial design and a master in urban design from Bartlett School of Architecture, and working now for EcoWise and working as a research assistant in the digital build environment. I'm very excited for this week and to meet you all and connect. Thank you very much.
Thank you. We're as excited as you. Yikun.
Hi, can you see me? Yeah, hello everybody. I'm from China. Currently, I'm a PhD student. I major in HVAC. Also, I do something about building simulation and energy efficiency, something like that. Nice to see you guys.
I like this, something like that. Great to see you as well. Tiago.
Hey, everyone. I'm an architect from Brazil. But I took my master's here in Sweden in energy efficient building design at Lund University. And I'm currently working as a sustainability specialist for White Architecture in Stockholm. Looking forward to the lectures and workshops.
Same here. 1 second. Yaichang. We can't hear you. You're muted. Jaichang?
Oh, was it me,
yes,
right?
You were muted. Yes, it was you.
Okay,
sorry. Jai, so, okay. Oh my God, like that was, wow. Sorry.
Yeah. Oh, yeah. Maybe you can go forward, but yes. Okay, hi, my name is...
Tell me how to properly pronounce your name?
Jay Chang, but you can just call me Jay.
Okay,
yeah,
I'll try.
Okay, thank you. Hi everyone, my name is Jay. I'll just call me Jay. And yeah, I'm currently working in the US as a technical designer, and I'm always interested in this computational design and everything. So I'm really glad to be here today. Thank you.
Great to have you. And now it's Jai Chung.
Okay. Hi everyone, I'm Jai Zhong. I'm now a senior student studying urban and rural planning in China. So glad to be here.
Great, glad to have you. Aditi.
Hello, am I audible? Hello.
Hello, we can hear you.
Can you guys hear me?
Yeah.
Okay. Hi everyone. My name is Aditi. I'm from India, and right now I'm in my final year of bachelor's in architecture, and I'm very interested in formative design, and it's something that I'm exploring in my thesis as well. So looking forward to this week.
Thank you.
Thank you.
There is another Jai Zhong. I'm gonna skip that because I assume that's the same person, like having two entries. I hope so, right? And then I'm gonna go to Lee Kinyon. If I'm mistaken, please jump in. Lee, Kim Yuan?
Hi, can you hear me?
Yes.
Hi. Now I'm majoring in urban design in London and at University College London. I came from China, but I have to apologize that now actually I'm having my academic courses, so the time conflicts, but I will record the workshop and review it later.
Okay. Thank you.
Thank you.
Atje Paratlu. Atje, just.
Hi.
Hi. Can't hear you very well. You have some issues with connection. Maybe we can. That was a very long hi. It's your connection is. That's a little bit difficult. I think it's the most interesting sound effect I've heard on Zoom since we started Zoom. Yeah, it's a mad audio sample. That's nice. I'm afraid, Ati, I'm gonna try to mute you. I mean, that doesn't even work.
Yeah, I tried, but it doesn't work.
It doesn't work. Okay, that didn't work very well. So I'm going to go to Peng. Thank you, Ati. We will try again later. Peng.
Hi everyone. I'm currently in Philadelphia, US, and I'm a faculty member at Thomas Jefferson University. Very interested in this workshop. Look forward to it. Thank you so much for organizing it.
Thank you as well. So I have still Buket and Eugene and Christina. Hi, Buket.
Hi everyone. I'm Buket. I'm from Turkey. I'm an architecture student. Just finished my second year.
Thank you. And then Eugene.
Hello, everyone. Yeah, I'm Yujin Yang from China, and I'm major in urban microclimate. And glad to see you. Yeah.
Glad to see you too. And then finally, I have Christina. Yeah. You're muted. Yeah.
Yeah.
Now you're not.
Hi, everyone. Nice to meet you again since last year.
Exactly.
I'm a fan. I'm a groupie. I'm a research assistant and a PhD candidate at EPFL in Switzerland.
Thank you. Thank you. And really glad to, since you came back, it means that we did something well last year. So we're happy for that. I just want to say one thing, just because the group is very diverse, right? And this is exactly what the purpose of this was, to be very diverse. And this is what DigitalFutures also mandated this year to have a diverse sort of group of students. So some of you are just finishing architecture school. Some have just started architecture school. Some have finished it 15 years ago and are professors, and some are research assistants. All of it is perfectly fine. No one needs to feel that they're need to catch up or something like that. We're all here to sort of share this experience together. And the idea of having a very diverse group is exactly what we wanted. So for us, it works perfectly. I'm not going to take any more time other than introducing Reinhard, who will give a lecture first, and then I will talk a little bit about InFraReD, what we're going to be doing today. You've gotten the schedule, and then we're going to go into a more sort of hands-on, what is the site? What are we going to do? What is the brief? Today it's going to be packed. So brace yourselves and get ready for a blitzkrieg of information, and then afterwards it's going to be more group work and for the next 3 days. But for the people who are watching live, we're going to be hosting all of the sort of lectures and hands-on tutorials and everything live, and of course the group work will have to happen in private, because no one really wants to spin out ideas in public unless you do, which we can also organize. So Reinhard, can you tell us a little bit about what this is all about and how we all came together? Because we all are here because of you and your efforts in the AIT, and the codec project. So if you can share a little bit about that with us, that would be great, so that we can have a bit of context.
Yeah, thank you very much, Angelos. I will also try to share my screen. You have to allow me, I assume. It's not possible at the moment.
Give it a go now.
Yeah, try again. Yes, now it works. Okay, so that's what I will give a brief presentation about something that I titled here, Artificial Intelligence for Architectural and Urban Design in General. As Angelos mentioned, I'm doing this since a while and in different contexts. So it started in Weimar at the Bauhaus University. And then I also worked at the ETH in Zurich and the Future Cities Lab in Singapore, where we somehow added bits and pieces to this idea of supporting design and planning by artificial intelligence methods in general. And finally, at the moment, most of it is grown at the Austrian Institute of Technology. So the group with Angelos, Narit, Sayosha, Theodoro, and others. So the AIT was so kind to fund us with some money to really push this topic. And that's also somehow the background where this InFraReD project emerged from, which you will learn much more and more detailed and better explained from Angelos and the others. I will just briefly mention it. And I will try to give you an overview of the thinking behind this whole development, because in the very end, what we always try is to support design processes in some kind of meaningful way. So we always try to find the path from some basic research towards the application and the integration in design processes. So that's a bit the story from the past. Now let's start. I mean, since I worked most of the time, at least partially in Weimar, and now again as a professor there, it's nice to start with Walter Gropius, one of the founders from the Bauhaus. And I mean, that's at least what he said, that he was not interested to invent a modern style, but a method to solve problems, of course, of his time, more than 50 years ago, which he approached with the methods he has at this time. I always like to show this example because that's what we know as some kind of not very lively, but typical modernist style, something that you can repeat, you can build it in a cheap way. And what you see here, it's somehow the basic idea of a parametric design model. So you have height related to distances. And if you reduce the height, also the distances you are reducing. So you could build this today easily in a kind of a grasshopper model. The result looks something like this, 1919. At his time, as mentioned, he worked about the problems he had and in the context that was important at this time. Of course, there you have found these beautiful cities that we appreciate today. They considered it as something that they need to overcome and build these car-friendly cities that we don't like very much today, at least in some place of the world. They want to have green spaces between the buildings and all these things that are very understandable at this time. Nowadays, somehow we try to overcome the results from this change in this modernist style, because it created a lot of problems that you all may know. So here, this satellite photo from Shanghai, that's an example that this modernist style was extremely successful, but it creates also a lot of problems that you see on the right side. It creates very problematic areas sometimes, not always. Of course, in some countries, it's also a meaningful way to approach some housing problems. Nevertheless, it's maybe not the best way to continue now in the 21st century as it was started in the 20th century. So the idea would be to find a way with our computational tools to find a new style for more or less similar problems. That's an image from a book from Mr. Watanabe, not very new, but it expresses nicely the idea that here, the idea was to give everybody enough sun and light, and you could have the same result just with a different form by the help of a computer. And that's what we try to do in general with the whole support of artificial intelligence in design. That's, I often like to call it cognitive computing in design. It's not meant that we make research about how we perceive design, how our cognition while design works. It's the idea that we support the cognitive process while designing by the power of computers. So that's what it's expressed by this citation, but I don't know where it comes from, but computers are incredibly fast, accurate, and stupid. Humans are incredibly slow, inaccurate, and brilliant. Together, they are powerful beyond imagination. And that's exactly what we want to create with these design systems. So they shall always interact with you as a designer and help you to become better somehow. Of course, there are tools, some of them like this famous city engine, not very new, but still fascinating. You can just click around and it generates cities on the fly based on some procedural model in the background. Surprisingly, this was never successful in design, more in film industry and gaming industry, but somehow designers have different requirements. These guys from HiArc, they promote a digital tool that somehow designs or generates building designs on the fly. You can sit together with your consultant and create the house in a few minutes, and then they promise that they can build it. For me, that's always a nice example how I imagine building information modeling systems should work, but they never work like it's shown in this video, that you easily can change room sizes and everything adapts. But that's something I always think that we shall be able to do. And of course, that's a very individual style of this company. But anyway, I think the technology is very nice. And then something that nowadays probably every one of you have already heard, the SpaceMaker guys, who really put together a lot of interesting and fancy technology that is available today. And they can really generate buildings and building volumes together with environmental analysis on the web, or at least it seems like a website. I've never tested it. I don't know how accessible it is, but these demonstration videos, they look really fascinating, that you can do all these things already in a commercial tool. Autodesk bought them now. So it seems that they managed to integrate a lot of the aspects that I will also present you in the following. But that's a nice example how industry is also working on a very nice level of research here. You can find these videos on the SpaceMaker website, so I don't show it in full detail. So that's how we started approximately 10 years ago with this floor planning system, where we started with the idea that the designer defines the requirements, like this, room sizes, the topology, so which room shall be neighbored or accessed by doors from which others, and then you can change it and you always get the spatial configuration or the geometry, a geometrical solution on the fly by your friend, the algorithm, the computer, that immediately helps you to find solutions for your requirements for the problem that you formulate here. You can also interact a little bit with the system. This was made at a time when there was no Grasshopper, or started a little bit, but these were individual programs based on some evolutionary algorithms. I mean, nowadays, our colleagues like Theodoro, they do this with machine learning in a way that's maybe much smarter, but this worked very nice at this time. Then we've done this project that's very similar to what you've seen with SpaceMaker, but here we developed it on the university in the context of these Grasshopper tools, where you can select a site, and then as a developer, you are interested about the building volumes, about the square meters you can build theoretically on this site. So this is generated on the fly by this tool. And you see immediately what's the possibilities that you have for a certain site, because it includes also the building regulations, in Germany at least. And you can find different here development structures or densities with height and distances and all these things. And you can explore somehow the design space, what's possible for a certain site. And that's a tool also developed at the AIT, where we try to explain a company who is usually not working with computational tools, how they can integrate it into their work processes, because that's usually one of the tricky parts, to find a way that offices that are working more in the traditional way with sketches, and somehow then they try to develop scenarios. And that's why you see this underlying sketch that's from the office. And then we merged it into this Google or OpenStreetMap image. And then you can design street grids. And if I go a bit forward, you can distribute somehow usage patterns, arrangements, and then it immediately generates the spatial solution for it. So here you get this first impression of what's possible on this site, and you can change all these parameters and have always the control about the amount of spaces that you generate, the densities and all this stuff, which looks not very different from this typical modernist style that I criticized a bit in the beginning. So that's why it's important to look at this one. This was developed at the Future Cities Lab together with a research group there that worked with Kees Christiansen's designers, and so they were design experts, but there was also a bunch of traffic engineers, building engineers, climate comfort guys. So many people came together, and one of our team members designed this parametric model where I just restarted, where you can somehow control all these basic parameters that allows you to vary these designs and evaluate again and again how good it is for these different aspects that the different engineer teams may be interested in. So this was the first part. I don't know how much time I have. I try to make it as short as possible. An important part of what we do in the context of these tools that we develop, and that you may also find here on this Decoding Spaces toolbox.org website. There are a lot of analysis tools, especially these network analysis, where you can generate or compute these typical centralities in measures in a network, also known as space syntax measures. But in general, these are typical graph theoretical measures, how far away it is from a point to another one. And this gives you indicators about qualities, spatial qualities in your city, how much traffic you may expect, how central your location may be. And then we link this also to the plots that you can somehow estimate the quality in terms of centrality, like here, for the individual blocks. And we also can link this to a simulation where you can make certain assumptions how a city will develop based on the spatial qualities that you find at a certain location. And more important in our context, that you can also generate, so you can extend the existing city with these tools that we offer in this toolbox. And you generate here the network and the parcels. And important here on the right side, that you can always check what you generated in the context of what exists, so how it plays together with the existing city. And then you can figure out if your design really ends up where you want it to be. I just show you this as a kind of a preview, what you will probably will hear from Angelos and the others in much more detail. you've seen that the analysis aspects are very important for analyzing generated designs. In this InFraReD project, where these images come from, then we can predict the simulation results or the results of relatively time-consuming simulations with the aim to make it faster, which is important in a design process, that you don't need to wait for hours or days, or I don't know how long, to evaluate many design proposals, but that you can get it as soon as possible, as fast as possible. And that's what's done here with this prediction, these machine learning models for solar radiation and here wind. So I skipped this. You will hear it probably later again. Another important aspect, that's what's called design space exploration. So in these very short examples, you have seen we can generate designs and we can evaluate designs concerning different parameters. And then we end up with the problem, what shall we do now with all this information, with all the generated designs and with all the evaluation criteria that we got? How to select now what we really like, how to communicate it to decision makers, how to deal with all this information. That's an example to somehow order a design model where you have different design parameters. So every design parameter can be called a dimension. And if you have more than 3, then you have a multidimensional design space, which is very difficult to visualize what happens in this space. And you see here these blue ones, these are some kind of input space or input points for, in this case, a very small design space, a set of parameters that generates these designs. And then you iterate gradiently or step by step all the design parameters that changes this model. And in this case, we use the self-organizing map to arrange it in a way that it makes it understandable for a designer, that between this and that parameter set, you generate automatically all these intermediate variants, and they are somehow building a gradient where you have islands of similar solutions. So that's a nice way to explore what you've generated. That's a different one, just where you may know it. That's a tool available where you can use this parallel diagram just to explore different sets of designs. If you filter them by the criteria that you computed by means of your analysis tools, and then you can just select the ones that are in a range that you find that they are useful. Going back to research at the Bauhaus University in Weimar, that's now what we thought about. How can we extend this conceptually, this kind of design space exploration, to make it understandable that each decision has a huge impact on the following decisions. So here we start with somehow the generation of building volumes very easily, and then we select some of them for somehow the next step in the design process. And you will then see soon what happens. So here you add them to a selection. That's also a tool that's available from the website. It's not written here, but at our chair in the university. It's by the way, it's linked to Grasshopper, so you can send the versions generated in Grasshopper to this web-based tool for this design space exploration. And here now, if you select some building volumes on the bottom level and you continue, for example, with the circulation design in the second level, then you can figure out that it's not possible to cover the whole design space, so the whole space of possibilities, but you restrict yourself with the decisions made when you selected the building volumes, and then adding the circulations. And then in the next steps for the facade design, you select these examples or these design variants, generate the windows. And once again, just forwarded, you see you can only reach certain areas of the design space. So that's just the conceptual background, what we explore in terms of figuring out what to do with all the information that's available. And a very important kind of space, device, setup that we built is the City Intelligence Lab. You may also hear more from Angelos about it, but that's really crucial for exploring what I've shown you in before. So we can generate designs, we can compute a lot of measures, but now the really crucial part is how to integrate it into a discussion process, into a decision process, into a design process with your design colleagues. So somebody can maybe generate the designs. There are experts for several kind of analysis, and there are people who made the decisions. So you need a way to communicate it. And that's by far more complicated than one may think. And that's why we built this space really to test possibilities with modern devices, with screens, with different views on the designs. And here are some, it's just one nice video on the City Intelligence website. You see many more made by our great colleagues here giving the workshop. That's just one example. Augmented reality, what we experiment with to explore these design spaces. Now I really go very, very quickly through these examples. This was just a design example or a collaborative project with a design office for a competition in Berlin, for a new district in Berlin. You see it here in the background, where we tried to link the generative capabilities of this modeling process with the workflow, with the work process of this design team working in this office, which was extremely difficult because, of course, in the beginning, they liked to have these great models where you can generate everything on the fly. But then they wondered how they can really use it for their design process, which was extremely complicated. And we thought it is a nice idea to give them a tool where they can draw somehow densities and usage distributions on a 2D map. And the model in the background always generates the corresponding 3D model. And you can distribute different densities at different places and change it on the fly. And in the background, you get this updated model with all the measures that you see behind these two people discussing here about the designs. But as often, this was more something that worked in our very nice academic context, but in reality, it needs to be fast, it needs to be somehow presented for a competition. And that's then always a very, very different work process as we usually do it. We are interested somehow in the outcomes of the tool itself, but of course, a design team need to include much, much more aspects. So that's really a challenge to include these tools that we develop into a real workflow for example, in this case, for a competition. And the very last example, what we do a lot is to work with Ethiopia. Of course, there are many countries worldwide who are developing much faster than we in Europe or otherwhere. So they really have the need for plants that are generated fast because they grow fast. And that's what we try to do. We have all these models and tools. But in this case, we really go to Ethiopia, to small villages where the people never have seen a generative model or something like this. And then we try to explain them what will happen with their village when it grows from 100 people to 10,000 people, how this can be communicated. That's also some kind of research that we are thinking of. That's a kind of a city intelligence lab brought to Ethiopia and trying to adapt it to the situation there, that in the end, you have the same problem here. You have design proposals, you have people who need to understand it, who make decisions and discuss it, but you don't have this fancy city intelligence lab. You are here somewhere in Ethiopia where you not always have electricity. So that's really tricky. And that's, of course, that's a vision that you can have this augmented reality model, but would be nice to proceed in this direction. Now, I hope I've not spoken too much. That's just the links if you're interested. So that's the toolbox, this Decoding Spaces toolbox, where you can download the Grasshopper tools and find many other examples. Of course, the City Intelligence Lab website, where you find many examples, what we've done at the AIT. And there is this online teaching platform that we developed in Weimar, where you can learn how to use these tools that I've shown you and see some results from the students. But there are a lot of open courses that you can take where we lead you step by step to learn how to use these tools. And of course, everything that I've shown, I've not done it. Many other people have done it, and they are listed here, as always in the movies. Just to mention them, of course, our colleagues who give the workshop now are important contributors, but many others as well. So with this, thank you very much for your attention. I hope it wasn't too fast, too much, but
I think it was great.
Overview.
I think you need the full 2 hours to give the overview, but like still, I think this was a great introduction, if you ask me. But like we can get like 1 or 2 questions perhaps from the students if they want to. Yeah, virtual club indeed. But yeah, maybe a couple of questions from the students if they have any. Thank you, Peng. Please feel free to just sort of like ask the question without raising a hand or anything. Anyone?
It was too fast.
Did you capture any of that? I think I have like very little to say after this because you've covered pretty much everything we are doing, and well, for me at least, this is like the reason why I came here in the first place was like the breadth and the depth of the research. But again, any questions from the students? If you can, come in and ask something, then otherwise I'll just go on with my presentation.
Hello, can I ask a quick question?
Yes, sure.
Okay, let me share my screen real quick.
Yes, please.
So yeah, Professor Mayhunt, that was amazing. I mean, while watching your lecture, I was like, wow, that was incredible. That was really great. I have a real quick question about it was almost the last year program, which is about like how to generate the urban scale up or the model through the number changes bar graph. I mean, all people love bar graph, right? Because that's really easy. So my question is there any other kind of input regarding to like FAR or building type or some, because currently I'm working in the US, Gensler, because we are doing a lot of some urban project, and I mean, seriously, this tool looks amazing. That will help us, that will save us life, seriously. But sometimes it's really hard to find a really nice number related to like FAR and some density and height and uses and BOMA. So just my question is there any other some possibility to consider about that input different numbers?
Yes, I mean, these are, of course, the basic numbers that need to be included into these generative tools, because usually a developer wants to have the maximum square meters that are possible at the site. So that's controllable. Either you can change it as designer, or we import it from at least at this project I've shown you, from this German building regulations, you can include them. But also the projects at the AIT, we also define these building types that we want to have. May it be a block type or individual buildings or row buildings or only individual standing, so kind of point buildings.
Understood. Got it.
That's possible.
So you can designate it. Mm-hmm. Sorry, but please go on.
No, you can, of course, ask. I mean, it's usually we adapt the tool to the project. It's usually not always the same kind of tool setup for all projects, but that's what we always do with projects at the AIT, for example, where we also offer consultancy services for offices that we develop a kind of a design model for a certain project. But usually the requirements, they're always a bit different.
Yeah,
and from my experience, there's no tool that serves every problem.
Yeah, absolutely. I couldn't disagree totally. So, right. So there's some other kind of similar program, but there's still a lot of problems, and especially to decide when it comes to design and also number, still we really need, I mean, just manpower and just all the people's labor. So
yeah, I mean, that's also a bit my learning from the past. That the greatest tools like City Engine that you have seen in the beginning, they do everything on the fly, but the possibilities to adapt it to your designers' needs and imaginations, these are very small. And also when we work with our students, they always have something in mind that they want to do. That's usually something every design team has, to build something individually. And that's why we somehow try to split up the tools. And that's why we use this Grasshopper, because you have these components, these small blocks for small solutions, and you can put them together in individual arrangements to come up with an individual solution. Because every time when I thought we offer something that solves all the problems, I needed to learn that it didn't work because it cannot include the individual requirements that maybe I thought they are stupid, but other thinks they are super important and they need to be included.
Yeah, I totally understood. Thanks for your answer. I mean, I totally agree with that, especially when it comes to a lot of algorithm or inputs. The Grasshopper just cracked, messed up. So I totally understand. But thank you. But this program looks amazing. That's incredible. Thank you. Thanks for sharing.
Thanks for your question.
Thank you. More questions? Anyone? No? Yeah. So I can continue then with my part. Reinhard, thank you so much for the time. I mean, of course, you're more than welcome to stick around and listen to again to the things I want to say. Thank you for the time, and of course, we will hope to see you on Friday, where we'll have the final reviews, and would love to hear your thoughts. It's very nice because in your presentation you covered pretty much everything we're going to be doing this week. So going from sort of like fast feedback and fast simulation feedback to parametric sort of like variations and generative exploration of design. So thanks for that. That's a great overview. I'm just gonna mainly talk about InFraReD, not much about everything else. So yeah, big round of applause again for the work that you showed. I'm gonna continue with my presentation. Slightly more boring. Can you see my screen? Yes. Super.
Yep.
Super. So before I go on with talking about InFraReD, I'd like to ask all of you to just like be sort of like here, more present, sort of like turn on your cameras and talk and like just get out perhaps of the Zoom cloud, which is like, you know, you're eating, you're visiting the restroom, you're doing everything like, and then there's like some background noise. Let's make the background noise forward noise. This is a kind request. So let's talk about InFraReD. And please feel free to interrupt as well as we go. Feel free to interrupt and say, hey, I don't understand this. Oh, this is cool. I want to know more about it or whatever. So let's talk about InFraReD, but first a little bit like, let's talk about the City Intelligence Lab before we talk about InFraReD. I don't know if you've heard of the City Intelligence Lab before. We are a lab within the Austrian Institute of Technology. The Austrian Institute of Technology is the largest non-university research organization in Austria. We're in Vienna. I'm Angelos. I'm heading the City Intelligence Lab. Narid and Yosha are doing a PhD with me in the lab, and Reinhard Koenig, who is like leading the Codec project, as we've talked about before. And Theodore Galanos has been working as a senior researcher in the lab from the beginning of when I joined the lab. So we're all here in one team, and a little bit like trying a little bit to sort of like convey that message to you. We do a lot of other things, like for example, urban resilience or urban analysis and simulation or computational urban planning and interactive interfaces and mixed reality and all of that I'm not going to talk about. So there's all of these other sort of like bubble of things that we're doing, except for InFraReD. So I'm just going to talk about InFraReD today. So this is how it looks like a little bit, the City Intelligence Lab when we're all pretending to work. And yeah, the question that I'm going to talk about is like, how do we design performance? How do we actually design with performance or design for performance. So instead of like sort of like designing and then evaluating, how do we actually design with real time and sort of like on spot understanding of what the effect, the impact of the design is. So I'm going to take you a little bit back. Some of you might remember, I do that in pretty much every lecture I give because I like it. This is generative components. It's 15 years ago, it was like the father or mother of Grasshopper or whatever, like, and it was like a long time ago before we had that sort of like all this capability of generative, you know, computational design, etc. So it was like a really, really long time ago. And within generative components, there was this connection between Ecotect and generative components, which would give you like a solar radiation simulation. It took ages to connect. It took like a lot of like DLL copy pasting and like installing things to just make it work, right? And you had to have like Ecotect running on as a software on one side, and then like generative components running on the other, and then somehow they managed to connect with it. It was a pain. And there we are today, having like all sorts of different tools that we can, you know, design performance with. So we have we are in a moment, we have like a great capability, which is to really understand the impact of our designs, like that, you know, in every sort of aspect, structural optimization, environmental, traffic, mobility, whatever. Like there's so many things you can do today with just like connecting, you know, Grasshopper plugin to your design. But that doesn't mean, of course, that we understand clearly what we're doing, but it means that we are at least have the capability of running this analysis, right? However, you know, if we take all of these sort of like different aspects of design, especially the environmental ones that we're like dealing with, and these are all specifically chosen because we want to deal with them in InFraReD. It takes a lot of like time and money and sort of like you know, effort, resources like computation or other human or material resources to do all of that, right? Like a wind simulation takes, I don't know, hours to run. A thermal comfort simulation takes even more hours to run, and you know, all these other sort of like analysis, they really take time and they're not really available. So this is what just to give you an example, sorry, I forgot this slide. This is what we came up with Theodore at some point. So like, you know, how much does it really cost to do a sort of like solar radiation or wind comfort simulation? So in terms of minutes, like this is just one study, one environmental study, it would take maybe like 500 to 700 minutes to run a CFD simulation, which is like a few hours, right? And if you were doing a thermal comfort, you're like looking into days essentially. So it really takes a lot of time. And then that's what InFraReD is about, is actually like reducing this amount of time. It's like giving you a glimpse, not necessarily the most accurate of those results, but giving you a glimpse of what, like, you know, your designs have as an impact in a very, very sort of like real-time manner. So I'm gonna take you a little bit through the sort of like history, like the story of InFraReD, trying to be a little bit funny here, just to wake you up or not allow you to sleep if you're on the other end of the globe. And well, the globe doesn't have an end, but yeah, you get the point. So this is what we're gonna be talking about: horses and zebras. So like you might have seen this before, you know, if you're doing all this like deep learning GAN business, where you take a a zebra or a horse, and you make it into something else by training a neural network to do that, right? And we're talking about these GANs, the generated adversarial networks. Theodore hates me for putting this image up. This is the most common image of a GAN, and and this is exactly what we've been doing in InFraReD as well. So you've seen other examples. So, you know, taking a sort of like photograph and creating some style, painting like style GANs or style sort of like transfer, etc., or taking yourself and make you look like your dad. This is the image that normally generates the laughter. But yeah, anyway, so what does that have to do with us? This is, I mean, if you've seen an InFraReD lecture before, you've seen all of that before, and you're like a little bit bored right now. But like, if you have never seen it, this is probably the most interesting picture, because one of that is a simulation, one of that is like solar radiation simulation that takes 20 to 30 minutes to run, and then or 15 minutes to run or whatever, and the other is a prediction that is done instantly, that is done in a few milliseconds, and we're using the GANs that we've trained. So how did we do that? We took, in this case, the city of Vienna. parcel the city, and we take like all the different parcels, and then we create the 3D models, and then we run, this is probably the image that you saw from Reinhard before, we run thousands of solar radiation simulations, right? You have all of these sort of like samples, and then you train a neural network, GAN, to predict. Instead of like run, you can predict. So you have on one side the real the real simulation, on the other the fake, and you're training, you're telling the GAN what it's doing wrong and what it's doing right. Essentially, I'm not going to go into detail. And then you're training it to predict the simulation. And then in this case, you see the actual results. On one hand, you have the input, which is the height map of the buildings. And then you have, on the other hand, the simulation and the prediction, which you can see are very, very close to each other, right? So that means that you can, instead of running anymore the simulation, if you train the network, it's like 90% accurate or whatever, you can actually just use the simulation, the predicted simulation anymore. And that means that it saves you a lot of time, especially if it's a CFD simulation and not a solar radiation. This was one of the first things we did with InFraReD, and it's like just a year and a half ago or so, or maybe 2 years ago. I'm not actually sure. I think it's a year and a half. And this is us essentially connecting InFraReD in Grasshopper in a really dodgy way, and just like sort of like creating a height map and then clicking a button and then essentially seeing that prediction. So it was the first integration of the GAN model that we had trained in Grasshopper. And you can see here, you know, you reset the image and then you get the prediction. From then to today, nothing much has changed, but a lot of development has been put into the sort of like integration of it. Like the model is still similar, but like we've of course trained new models, we've created new integrations, we've created web apps and other things that I'm going to talk about. But this is the core idea, that we trained machine learning models, neural networks, or deep learning networks, as you call them, to predict the simulations. And that's exactly the core of InFraReD. That's exactly what we are doing here, right? And then all of the things that you will be doing in this workshop are related to that. You're going to be using, you're not going to be learning how to train neural networks, because that's not the issue here. You're going to be using the outcome, so like the results, the trained networks, and you're going to be able to get this real-time answer. And you're like one of the first groups that we have, that we are trying this with. So in that sense, be patient, please, but also feel proud. So then we went into sort of like creating a lot of different sort of like studies within Grasshopper and InFraReD. So like this is just a promo video we did with a project in Norway, where we have implemented sort of like InFraReD and also other things, other analysis, which Joshua will talk about. So in this case, you see an example of how we can design with real-time wind flow. So in this case, you have like a park where you can position, which we can position in a sort of like design, and you can see in real time the wind comfort prediction of the sort of like the whole patch, the whole sort of like quarter. And you can move streets around, you can recreate your design layout. Of course, this is backed with decoding spaces and other sort of like parametric design capabilities. But the main point is that you can actually see in real time the wind simulation. So you can knock off a building and see how much percentage of your area gets more comfortable or less comfortable in terms of the wind. This is one of the examples we did. Then we went on to create like a web interface. So like people could just like try our tool, and then this was like a first sort of like web interface where you could just like position your location in the world, select the wind direction and the wind speed. This is what now it had developed in the beginning, and then just like immediately get a result. But it was like you couldn't design really on it, but you could just get a result out of it. And then we got integrated into Giraffe. I don't know if you know Giraffe. Giraffe is an urban planning, sort of like online urban planning tool, which has a lot of other things like financial or urban analysis, but also our wind comfort study. And here's where we developed the first sort of like interface on how you understand a little bit better the wind comfort on your site by selecting specific wind distribution, changing the KPIs, etc. And then again, you see how you can real-time design with the wind, and this is what we're talking about, like design with performance. So you can move a building around and immediately see what you're doing to your like courtyards here, for example. Like if you move a building and you rotate it, you immediately see what does it do in a certain direction in terms of the wind wake. So generally, that was also a very sort of like pivotal moment in our research, where we realized that this is really useful for people, and then we decided to develop our own web framework, web sort of like app. People are coming in the waiting room. I'm just gonna admit everyone, and then we're gonna I'm just going to change the waiting room so you can automatically be admitted. This I'm going to explain after we do after we form groups. But this is essentially the sort of like web app version of InFraReD, which we've developed very recently. A couple of weeks ago, or 2 or 3 weeks ago, it was released. So again, you're one of the first groups that work with these tools. Yeah, feel entitled. And this is sort of like our launch video, which is like, I hope you can't hear the sound, because I did, and it was a little bit too much. So yeah, here you can see a little bit like of a promo video of how we sort of like use the web platform, and here it is in the lab. Actually, the lab is a very immersive space to use any sort of tool, and kind of like makes it look a little bit more nice as an interface. But it's I hope you will find it an interesting interface as well. It's a very easy way to interact with InFraReD, with a sort of like core, which is the wind prediction. And sorry about that. And then the question, and this is what we're going to be talking here before I play the video, is how do you like change your mindset from this iterative design process where you move a building around and you understand the weight, you move sort of like delete the building and you understand the wind performance. How do you go into like a generative design process? How do you go into like a design process that doesn't involve you manually sort of like changing parameters, but involves you designing a solution space, a design space, a sort of like whole possibility of designs, which you then assess and sort of like find within, like explore the design space and find sort of like perfect solutions. And this is an example from a paper that Yosha was publishing last year at CMOD, the Simulation in Architecture and Urban Design Conference, where we have coupled InFraReD with optimization plugins like Octopus, and then we see how we can explore a design space rather than design. Of course, there's a lot of like fancy graphs flying around, but you get the point. So, and then one of the points that are really crucial for us is like, what is this interaction between the manual design processes, the sort of like ingenuity and creativity of the designer with the black box machines? So exactly what like Reinhard was saying in his lecture, where like computers are incredibly fast and stupid, humans are very slow and very very clever, and how the combination of the two can be crucial. And this is exactly what we are aiming for, and this is exactly what we're aiming for in this studio as well, in this workshop, where we want you to go and cross that barrier. Again, just a simple sort of like promo of what we're doing in the lab, apart from just like the InFraReD bit. Here it is, of course, again backed by InFraReD, but there's a lot of like AR business going on. This is Dielza, one of our colleagues that was with us last year, and then with Nari, they're like playing with a sort of like virtual design, augmented reality design. So a bit of the InFraReD team. This is all of us who are working in the CD Intelligence Lab, and Anna and oh, sorry, the names are wrong. But yeah, Anna and Christos. This is Christos and not Yosha. They helped us develop the web app, and of course, this is the website, as Reinhard also pointed out. These are my email and the address of the website if you want to learn more about it. And that's about it from me. I hope I didn't take too much time, because we really have a lot of things to talk about. So yeah, that's it. Any questions for me as well?
Maybe I can ask. So yes. all we can do with this like machine learning is like to predict the wind at this point. We can do like a thermal comfort charts, or maybe solar radiation protection.
Yes, I mean, I would phrase it differently. Like, all we can do is wind comfort and CFD prediction, which is, to me already a lot.
Yeah, I know. I'm just asking.
I just want to make sure that we like, at least from our side, we convey the message that this was not easy. But yeah,
definitely. But I was just asking because you said that areas that semi-comfort take more time. That's why I was just asking.
Just to respond to that, we also have models that predict solar radiation and sunlight hours. That's not as significant because they're like not that difficult to predict. The wind is probably the most like resource costly model. We have a thermal comfort model being developed, but we're not exposing that yet. We are not there yet. So when we feel comfortable with the thermal comfort model, we will expose it as well.
Thank you.
You're welcome. Any other questions?
I can jump. Just a question on evaluation of results. So have you a way to kind of, or are we sure that what the output of kind of our results, like is it a way to have visibility on what is behind somehow and evaluate that what we are using has these kind of parameters that we take into account to kind of...
I'm not sure I follow 100%. So are you saying, do we have a way to find the relationship between the parameter input and the results, or what?
Yes, something like if there's visibility on kind of behind the scenes, not of course everything, but the parameters that you account for, if it's kind of... I mean, it's a bit vague, the question, but
you will understand it more as we work with it. So as we work with the models, you will understand. Like, so there's definitely there's no behind the scenes in that sense. The only thing that's behind the scenes is like we've taken a lot of like simulations and we've trained the model. But what you're going to give the model is an input, which is essentially your model, in that case, your design. And then you're going to get back an answer, which is going to be the 1.75 meter like plane of wind comfort or wind speed, which is exactly what would give you, with any sort of like CFD simulation would give you if you were looking at pedestrian comfort or any sort of like wind comfort study at that level. So there's no behind the scenes in that sense. You will learn, and this is exactly what the process is about, what this workshop is about, how to understand how to set KPIs, how to sort of like understand what things matter in your design with your design cases, with case studies, and understand a little bit like, what your parameters have as an effect. Yeah.
Okay.
If I can do just a small comment on this question. So at least for the part of, understanding and sort of extracting some sort of, knowledge from all this, InFraReD is just like InFraReD by itself, the inference of InFraReD, right? Just the prediction is just a tool. So it's nothing to do with like design intelligence or knowledge, right? It's how you use that tool to sort of understand the relation. So in a way, InFraReD, the app InFraReD is our first step and many more steps at creating such a tool that will let you extract knowledge, right? But to do that, there's no tool that can do it instantaneously. It's always a process, right? It's always a sort of struggle with your design. So there are things behind it. It's up to us and everyone to sort of
understand,
figure them out. Yeah, and you can do it much easier because you have this conversation in a way, the real-time thing. So it's less painful, because if you imagine you were doing this, you were running it, then a week later result, then you were running it again, and a week, it's much harder to do this conversation. So yeah, that's my comment on this. Thanks for the question.
Thanks.
Any more?
If I could,
yes,
I could ask one. Thank you, Angelo. I have a more generic, the big picture doubt actually about InFraReD. I think it's clear that the advantages of the AI, for example, in the wind and the radiation, especially in the speed of the process. But InFraReD as a, let's say as a tool, let's put it this way, it's in my vision, in my understanding so far, it's a combination of a lot of different design parts or optimal values that we would like to find, and in a easier way to comprehend them So from what I see, it's very similar. I don't know if, correct me please if I'm wrong, that's why I'm asking the question. For example, with the Design Explorer from the Tomasetti. So I would like to just try to understand if the InFraReD it's something that it's actually in the same direction, you know, what they're trying to also achieve and show as a tool, as a visualization also, or you really see this pushing in a different direction that today I'm not really understanding.
Yeah. Maybe because the presentation was fast, I wasn't able to explain like in depth what we're doing. So yeah, I totally see your point. Like, you know, you understand InFraReD, like, or parts of InFraReD as also being a design explorer. So like Thornton Tomasetti, the design explorer tool that you mentioned is a parallel plot, sort of like visualization that allows you to, you know, select certain parameters and set certain inputs and certain outputs and just see a subset of solution, right? InFraReD is not very much related to that. It has that as a feature, as a sort of like sub feature of the design exploration, but that's definitely not the main part of it. So the main part of InFraReD is the ability to have, and the thing that you will be working on mostly is the ability to have wind comfort predictions in very small amount of time. So that's the core capability, is running a simulation or predicting a simulation that normally takes 5 hours within a few seconds. And that's the core capability. That's the breakthrough, right? Then on top of that, there is a lot of work on helping you to understand those sort of like simulations, those analysis. So allowing you to connect, to community, you know, to sort of like use the results in a way that are useful for your design, rather than just showing you an image and saying, okay, look at it, this is how much wind there is, and that's it. So helping you understand what wind means in your case, but not really a design explorer. A design explorer can be attached to InFraReD, or can be like, InFraReD can be used, and within our framework, so that's what we call it, the framework, we have design exploration, but you're going to be also looking into things that are completely different to the design exploration or the brute force approach design exploration that you're talking about with Thornton Tomasetti, for example, generating 1,000 options and just looking at them. With Theodore, the quality diversity work that you will be having a glimpse on relates more to generating solutions without really having a generative or a descriptive generative model, without really, you know, let's say, deterministically creating these options, by just sort of like generating new mutations of options that are not even part of your parametric description. I don't know if Yosha, Narit, Theodore.
Great. No.
Yeah.
You got it. Yeah. Thank you.
Yeah.
If you don't mind me chiming in for a little bit as well. I think like we're a bit too close to InFraReD, so like when we explain it to everyone else, perhaps we kind of assume that everyone already understands bits about it. When I first got into it, I was really kind of on board with this premise of taking this golden ideal of data-driven design that's currently this kind of, I'm going to call it tenuous thing, where they take so long to do, it's so much effort to set up your data, to talk to the consultants, to have a scientist or something, or an expert, perform data-driven analyses to inform our design. And so often it's something that's far down the design process. Something as long as CFD, for wind comfort and wind flow. To run those analyses, as everyone has said here, it's about 5 hours or longer, and communication with the experts and meetings and so on and so forth. With InFraReD, you're condensing something down to 5 seconds of effort without the expert required. So you're able to take this idea of performing analyses, using data to inform your design, and you can bring it to the earlier stages of design. You can make smarter decisions about your design without really having to go through all the faff really. And I think that's a really core point. And that really makes InFraReD stand out, I would say.
Thank you. Joshua, do you want to add something?
Question, please.
Yeah, I mean, like, yes, if Joshua doesn't want to add something, because I saw him unmuting.
Yeah, can you hear me?
We can hear you, but we can't hear Joshua. But yeah.
Okay, perfect. So you know how in CFD it's so hard to take into account the context, like the vegetation and trees or water. And I feel like this kind of input is very important to be able to do the comment about the wind flow and so on. So did you try to do something about the vegetation? Because you showed us the simulations just for the building typology. But can we really take into account the trees and also maybe the yeah.
Yeah, so
great. Yeah.
Thank you for the question. It's a great question. For wind flow and wind comfort, no, we don't yet take into account vegetation as vegetation, right? You can if you want, and it depends on the kind of vegetation. For example, there are like low vegetation barriers, right? Not everything is a tree. You could take into account as geometry and assume it has some sort of, is opaque and it won't let any air go, and some of that happens. But we don't have porosity included in canopies, for example. The main reason for that is that our prediction happens at the human level, right, at the ground level, and we haven't integrated yet the trees, which will be integrated once we have thermal comfort, though, because there they do have a big impact, right? So that's the short answer. Let's say it's not yet in wind; it will be in thermal comfort.
And also, is it possible to do this kind of simulations, not just for outdoor, but for indoor?
So it's definitely possible. Anything that is a sort of, map-based metric, you can do it. It's possible. We haven't done it in InFraReD yet. It's big to begin with, is a bit out of our scope as an urban design, let's say, focus, but it's definitely possible and it might happen in the future.
Yeah, perfect. Thank you.
We have a question from Pen in the chat. I'll just read it out. He was just wondering, I was wondering if InFraReD integrates VR as part of the visualization, as I saw it in the video. I can speak to this. It was kind of a hacky solution. So InFraReD is kind of the borders of what is InFraReD, what isn't InFraReD is a bit strange, because we've done a lot of different integrations between different technologies. That VR part was a link with the machine learning models running on a local server on a machine, connected through Grasshopper and what's that called? There's a tool that the guys down in Melbourne made that allows you to do AR. Actually, it was not VR. I don't remember the name of it.
Hologram?
Fologram, exactly, yes. So we use Fologram and combined with a custom written Python code with our machine learning running on a local server. That's not something we're currently going to offer nor teach you guys, because in all honesty, it was a terrible implementation. It took me and Joshua and a few other people a lot of time to get it up and running and wrapping it up and so on and so forth. It's not ready for public consumption yet. InFraReD does exist in other forms through the web app at infrared.city, something that is in its presentable manner that wraps these complex machine learning models with complex wiring to get data in the specific format, blah, blah, to a more general audience. So yeah, yes, we played around with it, but it was more of a packy solution.
Yeah, just to add, I think for visualization, it works fine. Once you want to integrate interactions, then Hologram doesn't work so well anymore. Then you have like lags and delay. But for simple visualizing what you have, it kind of works, I think. And as we are showing you how to connect InFraReD web platform and Grasshopper, you can also kind of simply add that connection within this workshop in the end on your own. Yeah.
Is topography considered in the CFD analysis? Theodore, do you want to take this?
Sure. So I answered on the chat, but we can do it.
Oh, sorry.
Also. No, it's not a problem. It's currently not included. It's an assumption that we made, which is not very foreign in most of the practical, let's say, situations where you will do CFD. In a lot of the cases, there are assumptions about, let's say, flat terrain, especially with how current construction practices are, at least in most of my experience. But there are sites, of course, that do not fit in this approach. But yeah, currently topography is not included. So we assume flat. In the future, we will try to include it, and just so that we can have a variety of, let's say, different approaches. But yeah, it does bring a lot of complexity in all things, not just the deep learning or AI side of things, but also in the practical CFD side of things. So it's something that we avoided at first. Yeah. And as a question, maybe summarizing all this, it is important to know that InFraReD is a tool that you use for different reasons that you would use, let's say, something that does a CFD simulation, right, or a wind conformal study. Is a tool for conceptual design, right? So it's meant to be, as Nared was saying, early in the design, really provide, let's say, a tool to extract, create, design intelligence, communicate, iterate and understand, what you can do in your design space. You would never validate with InFraReD, right? We don't propose that you should validate with InFraReD. You should validate once you have some designs, you should do it in the detail, but you should ideate with InFraReD, definitely. And as you will see, I think it's a very interesting experience doing it, especially across this type of metrics. So yeah, there is another question by Mohammed. So how the processing happened? Yeah, so the models, as Angelos was saying, is computer vision models. So yeah, it happens on the level of visual data, right? So that's the short answer of this, and we shouldn't go too much on deep learning technicalities, I think, since it's not the topic of this year's, let's say, course. So I don't know if there is any more questions.
I have one, just a quick.
Sure. Yeah.
Go ahead.
Theodore, I think maybe this one is more for you. Just for this the CFD analysis, what tool was used for generating like the image itself? Was NSYS or was Fast CFD, for example, the plugin that already exists for the Grasshopper?
Sure.
As a curiosity.
Everything was open source, so we used OpenFOAM, and it was real scale urban simulations at specific. Not real scale, at a specific scale that is very, let's say, regular in practice again. But it was OpenFOAM, and steady state simulations, quite accurate, time consuming and all this stuff. That was.
Yes, thank you.
Aditi. Yeah.
Yes, hello. So I have a very specific question. So I have a very limited experience with CFD through my research, but are we talking about street level CFD analysis, like around 10 meters high? Something that I was wondering. Are we talking about just those?
Okay.
Or can we switch them between? Yeah.
Yeah, it's a very good question, actually, practical. So at the moment, it happens at human level, right? So imagine 1.5, 1.7 meters, right?
Right.
We can and we will extend in the future for different heights, but it's very difficult, at least right now, to extend it for arbitrary heights, which is the only thing that people would be interested, right? So if we went and said we have another one at 10 meters, then someone would come and say, but can I do it at 12.5? So it's really hard. So we chose a level where really applications happen. This is the pedestrian level, right? So that's what you can do. But the other question, the way you started, makes me also say the other thing that's very important. When you said that, you have limited experience and all this stuff, the other cool thing I think about InFraReD, or we think, is that it will allow everyone that doesn't have experience with these tools, right? Maybe not even what CFD is, to actually experiment with these metrics. So I hope that this will be interesting for you. Yeah.
I agree. For my research, I went through a long process of getting these softwares to work for me and going through all these limitations that different software has. I mean, some softwares allow only poly surfaces and you can't really work with mesh, and all those things are very time taking. So I'm very impressed by what you guys were able to achieve. Also to just for the future ideas, how do you guys see it building forward? I mean, do you just add database imagery and those simulations to your machine learning program, and will it give the same result further? I mean, for example, right now we're mostly talking about rectilinear buildings. I mean, it makes sense for now, but for it to cover more design iterations and ideas, do you see it growing towards that?
Very good question. Very good question. Thank you. Actually, excellent. It's a couple of points there. So for the last point of more complex geometry, it is already supported, right? So we used the real world as inspiration for our data set, and there is a lot of, I assure you, a lot of weird geometry in the real world. We spend a lot of time looking at it. So you can already have like, circular buildings or, convex buildings or whatever shapes you can imagine. So that's nice. And the other question I can answer from my part, because we, as a team, this is also our value, I think, that our strength. We have different points of view, right? So from my part, how InFraReD will move forward, at least from the things that I'm focusing on, is this idea of what happens now, right? This is a question I asked people a few days ago. Like, I presented them, okay, this is InFraReD, it does real-time prediction. So what? What would you do with this, right? So my question is this: what can we do with such a tool? And this is, I think, what the InFraReD tool will try to answer. Like, what new thing can we do? My answer, again, because it's my point, the specific point of view, is that it will be this exploration, right? This open-ended design. But of course, for that to happen, you need a lot of other things, like, Nari talked about, and we'll talk about backend and deployment. Is very difficult stuff to do, right? Yosa will talk about so many other different metrics. So there are many avenues to go, I think. We are still exploring them, and this is a perfect place to figure some of these out. But I hope it leads us to something more open-ended than what we have today. I hope that's a good answer.
Thank you.
Do we have another question? If not, we can go to one more small presentation.
Yeah, I think that was a good transition. Actually, now we are going to talk a bit more about the workshop and what you and us are going to do. Let me share my screen. Can you see it?
Yep.
Yeah, okay. So this is the title of our workshop, right? Performance-driven generative design and practice. And the overreaching topic, I think, as it's already obvious, is around the question how we can establish performance-driven design, performance-driven design into practice. And I think it's also pretty clear that it's quite tricky and complex task after all, involving many different steps coming from time it takes to compute a solution, the data it needs, set it up, and also what to do with the data in the end. And throughout the next few days, we want to share some of ours and other existing approaches toward getting closer to this goal and test and discuss them together with you. Around a small urban design project, you will work together in groups using the tools we're going to share with you throughout the next 2 days, including different versions, so to say, instances of InFraReD. Yeah, maybe a little bit background. I think we covered some of that already. That in practice, the simulation-based impact assessment in early design stages is actually seldomly used and applied, despite the fact that a lot of these simulation tools actually exist: CFD, traffic simulation, microclimate, noise, site and view analysis. For all of that, there are tools available, many times even in open source and for free, but they are not used. And we highlighted here a few reasons why we believe that is the case. And these are kind of the obstacles which we seek in our work at CAL also to kind of come over. So the first of all, I think we covered it: long simulation times and setup costs. Physics-based simulation like CFD take hours. Others like traffic simulation might take a lot of effort to set up initially. So it takes more than the building geometries and maybe some surfaces, but yeah, kind of a lot of more data points that are sometimes not so easy to gather. Then another point is expert knowledge is required. A lot of simulation tools are not really made user-friendly because only a small amount of experts need to use them. And moreover, usually they are developed individually and all operate in their own logic. So it's would be a lot of learning and relearning for one person or one firm to be expert in all of them. I think a very important point is the third one, that's just an overall weak integration with design tools of impact assessment, simulations, and design tools. So you need to export data from CAD softwares to different formats and softwares. Same with the results, they need to be post-processed individually for each simulation and then turned into a presentable form, which all takes a lot of time. It makes it unfeasible to evaluate more than 1 or 2 variants, usually at the very end of the project. And then it's usually too costly and late to make any major changes. And to illustrate this further, here's an exemplary flow chart of a project. All this goes down, also how we work sometimes at the IIT with the more traditional models. So we have, let's say we have a architecture company, they make a design, they send it to us, then we have different simulation engines. We need to process their input data for each one individually, run the simulation for a few hours, then analyze it, extract the data, create a PowerPoint, unfortunately, each time, and then either send it back to the client or even have a meeting for a few hours in Zoom or something. And only then the architects or urban planners can start with a second iteration of their design. And one of the cycle can easily take 1 to 3 weeks, given all the communication that's involved in between. So it's really slow and you cannot really test a lot of solutions. So we thought we need to tackle these bottlenecks. And for the time aspect, I think the CFD model is the best example. We train with machine learning models and surrogate models. We can, in the CFD case, I think it's around 10,000 times faster. So that's a pretty big deal, even though the accuracy is less, but for early design stage, I think that's absolutely fine. And the remaining 3 factors, the effort it takes to transform data, lack of integration to design frameworks, and time-consuming data processing and presentation, all can be probably best tackled by integrating both design, simulation, and result communication into a platform and into an integrated platform. And especially if this platform is web-based and that everyone can just access through a browser. And this is kind of what we're trying to do with the mentioned InFraReD platform. So far, what is live and running are the CFD models and 2 other machine learning models. So it's kind of focused on that, but we planned it in a way that we can, in the future, extend it by further simulation engines to get to make it able to use this platform for more holistic urban design evaluation. Also integrated are some modeling tools, so you can change buildings and so on. You can manage snapshots. I think Angelos will go through over that. And snapshots are nothing else than design variations. So I think that's already quite a big help. And in the end, there's also some exploration tools. So we try to integrate a lot of the points that used to be not that integrated. Along with that, we will provide you as well. This is kind of what we're going to show you the next days. A plugin of InFraReD, a Grasshopper plugin that allows you to combine it with other simulation modules or generative models or whatever you can do in Grasshopper with our fast prediction. In the end, you can upload all your generated models and solutions to our platform and use it to visualize and show it to stakeholders or wherever you want to show it to, and even still modify it a bit. And this is something we just finished develop today, so to say, as Angelos mentioned in the beginning. And your task is then to take all these tools, combine it with whatever knowledge and skills you already have, and bring them together in a performance-driven urban design study you work on in groups throughout the next few days. Additionally, we prepared a site and a 3D model. We will send it to you. And then we show you throughout the next 2 days Grasshopper tools and also InFraReD, and also some additional optimization tools and so on. So we really try to cover different aspects of whatever can fall under performance-driven design. And yeah, I think it's mostly about together with you guys to explore what is possible and what works, what maybe does not work so well. And it's kind of the first time we're testing these tools together in this constellation workshop. Now that's an overview of the schedule for the next few days. Today, what happens next? We form some groups. Angelos will show the web platform in more detail, and then Narek will go over the Grasshopper integration between web and InFraReD and Grasshopper. Then your task will be to come up with project ideas following a template I'm going to go through soon, get a bit familiar with InFraReD. On the second day, I will show a bit how you can integrate InFraReD into other Grasshopper workflows related to performance-driven urban design and some optimization workflows. And then you have to refine your project ideas, implement all necessary simulation models. And the third day, Theodore will take over and go quite deep into design exploration and some quite new methods in urban planning called quality diversity and map elites. And then at the end of each session, we will have a short review of your projects and how far you got and if you have any questions. Yeah. You see here, we also share a link to this later on. To the site, we choose Barcelona. This is just a suggestion. So if you have an idea, maybe a previous project from your professional life or a university studio, and you think like, oh, maybe I would like to apply some computational methods and analysis to it, to see what I can make out of it, that's totally fine. We just suggested this site in Barcelona. It's part of the European competition, quite medium-sized area, an industrial area that's actually about to be redeveloped. You see here is some residential areas on this side. On the other side is probably a bit how to connect both areas with another. So I think there are like quite some questions can be answered and debated. And the important thing is that you need to have design within a performance-aware workflow. So you need to decide what simulations and engines you will use and what performance indicators you want to compute. And to help you with that, we provide you with this tiny template that is very simple. You should start by defining a vision for your site, then translate it into actionable strategies. And from that, you can derive indicators you can measure your success with. So the vision, of course, it's your creativity, whatever you want to achieve. And then translating it into actionable strategy, you should think of what design parameters can we change. I mean, we are like urban planners and architects, so it's probably the built environment, streets, buildings, and so on. And what design interventions are needed to kind of achieve the vision. That is then further detailed out in deriving measurable indicators to measure whether how much success or failure we achieve given our vision and design strategies. And here's a little example. Let's say that the vision was creating a certain number of residential units to promote walkability and create a new vibrant and integrated local center in a site like I showed before. And the actionable strategies could be something on the top, very simple, provide 600 residential units. And it gets a bit more abstract. Promote walkability, we can do that by short walking distances to the new center and transit stations. Vibrant and integrated local center, attract many people to the quarter, provide a high degree of pedestrian comfort along public spaces. In the end, from these, we get even more detailed on the number of residential units. That's easy. Average walking time to stations, and so on and so forth. And you note the latter one here on the right side are actually measurable. We can capture them with one number. The average walking time might be 2.5 minutes or something. And we need that to kind of make this data-driven comparison in the end between different solutions. So this is a very important process, I think, to come up with a vision, define strategies, and then really having measurable indicators that boil down to a few numbers. And yeah, that was it from my side. Are there any questions?
Thanks, Chris.
Yeah.
Okay.
Otherwise,
so if there are no questions, so what we can do now, we will take a small break. I think we all saw a lot of things, so let's take a 10-minute break, right? But before we go, I will post a mirror link in the chat. It's already there, so just take a look. Let me know if it works, right? And in the mirror link, this is where we can, sort of co-create and do things. You can create your own spaces, right? All these things. And if you go right now, the content is not a lot. It has a few things, but it's not a lot. On the right, you will see a small circle, right? It's a sort of like, we put some parameters of what you like to do or what you prefer. You know, you can think outside of these parameters, but let's also think with that. And if you can put a post-it with your name at a location that approximates, right, what your profile is or what you think like you are interested in. And we will use that to sort of make the groups after we come back, right? So in a way to co-create together, you know, how we make groups, because it's always a difficult process. So yeah, we will take the 10-minute break. Feel free, you know, step away, move around and stretch, of course, and we will be back right after. Thank you.
Hello, hello. So, thank you for, we can keep, I think we can keep the, I can share, we can keep the group forming on. Give me a second. Yeah, you can all see my screen, right? I see some clustering, but not much. I want to say one thing. Antigone, can you please remove yourself from one of the two points? Because we need to have one. Thanks. And everyone else who might have more than one post-it, please remove yourself if you've positioned yourself more than once.
I still did put myself in some place.
And also, Hager, if as you're not going to be forming one of the groups, I think it would be best if you do not position yourself in here. So let's see. Okay. Theodore, you can also move yourself out of here. Thank you. You had a backup. So are we all done? Can I get some faces over here? And some interaction from the students, please. So we're all done, right? I see some things moving around still. So now we need to form the groups. We need to form, I think we are in total, let me think, we are 30, but then it's 4 of us here. So it's like 26 minus 125, right? So we're 25, correct? Probably. That means we can form 5 groups of 5 members, and that's how we're going to do it. So let's freeze this now, and we can see what sort of like group forming we can do. I'm just wondering, because there's like Peng and Aditi that are like so far away from everyone else that maybe some of you want to move closer to Peng and Aditi, and therefore, or Peng and Aditi can move a little bit closer to you, so we can like do the clustering a little bit easier, so that we can sort of like, yeah, so we can sort of like figure out the 5 groups. Yeah, so I would suggest, like, I'm going to change like the colors of some of you so that I can sort of like consider you a group. I suppose I will do this like that. I'm just going to arbitrarily do it. It doesn't need too much thinking. So I'm going to change all of these colors to become blue. This is group 1, 2, 3, 4, 5. This is group 2. I'm doing this absolutely randomly, and I think that's perfectly fine. Oops, someone moved there. And I'm going to take the liberty of moving you here as well. And with Ozge together, you're going to make another group. And orange. I'm missing some people, I think, because I only see 4 groups of 5. So who am I missing? 2, 3, 4. Is someone here that hasn't positioned themselves in there? Hello, are you with me? Can you?
Yes.
Is anyone here that hasn't positioned themselves in this
circle?
Okay, we have a few people in the chat saying they're not in. I can't seem to get it to work. What do you mean by that?
Yeah, what do you mean by that?
Open your microphone, by the way, anytime you want.
Yeah, you can just unmute yourselves and speak. Like, this is, the idea is to be interactive.
My video is saying that is not allowed.
Huh.
The camera.
Yeah, I'm kind of having some technical difficulty as well.
Are you talking about the video? I'm talking about the mirror board. Have you positioned yourselves?
Yeah, the mirror board itself. Just give me a second. I'm just trying to figure that out quickly.
Yeah, thank you.
Okay, we have one more.
I will add the last group of people together in over here. Is it just Z or is there anyone else? If you don't see your name in here, then you will have a problem later on because you won't be able to follow the workshop. So if you haven't added your name there and you don't see your name and you don't add your name, then we have a problem. So please do so. Atia, did you manage to add your name somewhere? We can't hear you, you're muted.
Yeah, I'm in the simulation group.
You're in the simulation group. I can, there you go, Atia. All right.
Yeah.
Tiago, you're also there. Saket, you're also there. Rashid, you're also there. Yeah, and Hikyun. All right. Group number 1, simulation. We don't have to call you group simulation group. We can just call you group number 1. Okay. I want you to all write your emails in the chat so I can send you. Eugene says can receive the code from Miro. You don't need a code. Stop sharing. You don't need a code. You need just a link. Sorry about that. Okay, I've stopped sharing the. So let's do it like this. I've stopped sharing the Miro board. So if you can add your emails here in the Miro board, actually that would be easier for me. So just put your emails in that little box, and that would help me as well. So we'll do the same for the other 2 groups. Be aware that if someone is already like editing the post-it, you are not able to do it as well. Thank you very much for that. So while we're doing this, I will start preparing to show you the web app, the InFraReD web app. Hope that will work like a charm. Nari, I'm looking at you.
Shaking in my boots.
Yeah. So let's see. Once I have the emails, I can start showing because I don't want you to be paying attention to both things at the same time. Okay. And what you will receive in your emails is the credentials so that you can log in both to the website and to use for authentication with the Grasshopper plugin. So they're really critical. Those emails, keep them in hand so that you can fetch the credentials when needed. I mean, I suppose you will only need to do that once, and that would work afterwards. So let's see. I think I got all emails from the first group. I almost got all emails from I got all emails from the third group, and I'm waiting for the other two groups. So yeah, getting there. We might be a little bit late today. Just a fair warning. We might be slightly late with everything we wanted to show. I hope that's okay with most of you.
Maybe quickly let people know what we're showing after, like.
Yeah, so we're going to be showing the InFraReD workshop, so the InFraReD web app, and then the Grasshopper components. Yep. I was pretty sure that the first day would derail a little bit, like time-wise, because we had a lot of things packed. But I think from tomorrow onwards will be fine. Okay, so almost there, and I think we can start. Oh, someone moved the circle. Not bad. Cool. Okay, so I'm going to start with the web app. Yep. So pay a little bit of attention here, because this is something you will be needing in your work. So can you all see my screen? Yeah.
Yes.
Yes. Yes. Yeah. It's not going to be exactly the same in your screen, because my screen is smaller or my screen is bigger or whatever. It doesn't really matter, but you know, you're going to get there. So you're going to use your credentials that you're going to get in your emails, and then you're going to be able to log in. Yeah. Once you log in, this is one account per group, right? We did it like that because we can't really have 30 accounts right now running, because it's probably better for you, for your collaboration as well, to have one account per group. So every one of you essentially kind of like joins one account on InFraReD, both here and on the Grasshopper side. And that would allow you also to see each other's projects. So you can also collaborate in the web app. You can collaborate because whatever you do is reflected on the others on the other account. I wouldn't go too far with that. I wouldn't just like change a design while someone else is changing a design. I would just use one sort of like computer or one sort of like user to do that. But yeah, so how do we start, right? You get this page and then you can do two things. You can either load an existing project or create a project. At this moment, you probably want to create a project because you haven't, you don't have any project there already. Something is not working perfectly. Okay, so here you go. So in my case, I will choose my favorite spot because it has the best sort of like data available. So I'm going to go to the Vienna International City Center. So this will fetch essentially data from OpenStreetMaps. So OpenStreetMaps has data for the whole world, but not necessarily accurate. So you might not have the heights correct or whatever, but it can give you from whatever location in the world a sort of like condition of the context. So you need to have a context to start with, right? In this case, I'm going to choose the Vienna International City Center, which is a good sort of like, in terms of data, a good location because it has enough data, also height, so I don't have to fix math things here. So I'm going to click continue. I'm going to call this DigitalFutures InFraReD demo or something, doesn't matter. You can give it a name. The thing that you need to remember is if you need to make this 500, we should have had it by default 500. It has to be 500 by 500. At this stage, make sure that these two numbers are 500 by 500. This doesn't really matter, but keep it at 10. Yeah. This is the analysis XY sort of dimensions, but at this stage, we will only support these 500 by 500 analysis mode, right? So you need to keep these values fixed. So if I click continue, what it will do is it will create the project and it will retrieve all the data and put it in the project, sort of like the context data, and you will essentially be presented with the initial sort of like site. This is the context. And we have, if you see here, we have three modes. We are currently in the context mode. In the context is where you're selecting and setting everything that relates to your context. So first you create your context site or your context analysis and everything, and then you go into design, right? And this is important to understand the different steps here. So within the context, what you can do is, first of all, you can look at the website, you look at the site and see if all of the data is correct, and you can amend certain things. So for example, if I can click on a building and I can click on the information button here, I can change the height of that building and say, you need to select it and change it and make it 30, for example, because I know that this is a 30-meter building, if I know, for example. You can also change the use case. At this moment, we might not really need that. I'm not sure if Yosha has something planned for that, but you can also change the use case. And once you want, you can also change the use case. And once you want, you can also change the use case. And once you want, you can also change the use case. And once you want, you can also change the use case. And once you want, you can also change the use case. And once you want, you can also change the use case. And once you want, you can also change the use case. And once you want, you can also change the use case. And once you want, you can also change the use case. And once you want, you can also change the use case. And once you want, you can also change the use case. And once you want, you can also change the use case. And once you want, you can also change the use case. And once you want, you can also change the use case. And once you want, you can also change the use case. And once you want, you can also change the use case. And once you want, you can also change the use case. And once you want, you can also change the use case. And once you want, you can also change the use case. And once you want, you can also change the use case. And once you want, you can also change the use case. And once you want, you can also change the to sort of like move a building around, you can also do that. For example, if I say this guy is actually not positioned there, I can move it like to where I think it's the correct location, or I can even delete it by clicking delete, or by sort of like hitting this delete button. Data layers are not that important right now. I can delete the whole context. I'm not going to do that because I don't want to. And I can also delete the site building, so I can select the site. I can sort of like here set my site to be a certain location, and I can delete only the buildings of that site. I mean, I could be doing that. I could sort of like set the site to be, let's say, this part. I hope I'm not going to break anything. All right. And delete the site buildings. So that deletes all the buildings that are related to the site that I want to work on. And of course, you can import project, but that's not relevant right now. And of course, you have like the two top view modes and reset camera modes. When you're designing or doing some things with the design, you need to sort of like be in the perspective mode. The next thing you do, which is the most important part, is choosing what analysis you want to run. So in this case, I can add different analyses. I can add the wind comfort, the wind speed, the solar radiation, and sunlight hours, which are the models that we're exposing as we speak right now. So for example, I want to run a wind comfort analysis, which is of a wind speed of, I don't know, like 12 meters per second or something. I don't know, this is a bit too much, but it doesn't matter. And yeah, anyway, 12, you need to really find that sweet spot. There you go. And the wind direction of, let's say, around 180 degrees, right? And I want to add another sort of like analysis, which is going to be a wind speed of something, I don't know, like 10 meters per second at another wind direction, or at the same wind direction. It doesn't really matter. It's up to you. You can also add more than one wind comfort study. So for example, let's assume that you're interested in 180 degrees, but you're also interested in wind comfort at, I don't know, say 8 meters per second or something like that at 90 degrees wind direction, right? Which is a different sort of like analysis. You can have that as well. You don't need to have one wind direction analysis. I won't go too far with it. I will just create a few. In the case of Vienna, you can also have solar radiation, which has no input, and sunlight hours. This is just for Vienna. It doesn't work for the rest of the world because clearly the model is trained for Vienna. These are the analysis. Once you've done all of that, you can then go into design. So once you've selected what analysis you want to be running in every design, you can then go into design. So in the design, you can do, of course, designing buildings and all these things, which I will explain, but you can also just run the analysis, which is the first thing we will do. So here you have the settings. You can still change the settings, but we would advise you against changing the settings right now, unless you're like searching for something. So because the settings are going to be changed for the whole of the project. And then you can look at the results. If I click run here, what it will do is it will take this result, this context, and send it to the backend, and then bring back the results. So give it a minute. You see now we have wind comfort already sort of like appearing, and then we have solar radiation. They appear as they come back, but they will be in the order that you select them. You have wind speed and all of the different sort of like analysis mode that you select. So you have wind comfort 1 and wind comfort. It will just rename wind comfort to wind comfort 1 because it's the second wind comfort analysis you selected. And this is giving you also some metrics. So how much of the percentage of your grid is comfortable for sitting long, for sitting short, for walking slow, or for walking fast. And it just gives you like a comfortable percentage of comfortable areas. So like you have 1.6% areas that are not comfortable and a very small percentage that are dangerous. Because if you see what you see here is essentially the different sort of like Lawson's criteria. I don't know if you've ever heard of that. Like I think Theodore can go into more detail in this. But essentially, it gives you like a certain criteria by which you can categorize the wind in the wind comfort. So if it's like comfortable for sitting long time, or if it's comfortable for sitting short time, or if it's only comfortable for walking past slowly or fast, or if it's uncomfortable or dangerous, which you don't see in that legend, but you see here. In some areas, you have uncomfortable areas. Dangerous areas I don't see right now, but there must be something. Wind speed gives you a very different sort of like analysis, which is like a linear 0 to 1 scale of wind same sort of like, you can get a mean wind speed and a maximum wind speed and the percentile 95% of the time. And then you have the second wind comfort, you can see in another direction, and a slower speed where you get uncomfortable situations. And solar radiation, sunlight hours, of course, are there. If you're interested in that, we can go into detail. You can get the sort of like average solar radiation that falls on the sort of like specific part of the grid, or average amount of like sunlight hours. So that's running one result, right? You already have that result. So just keep in mind that if I want to get out of the results, I can just click sunlight hours again. So like when I click on it, I see it. And when I click on it again, I am getting out of it. And now I see my design, right? Let's talk about snapshots at this moment. So a snapshot is not really a save button. It's essentially adding, creating a new sort of like canvas for you and design. Because everything you do, if I move something around here, if I design something, it's saved. Yosha, you want to jump in, or were you unmuted from? Oh, no, sorry. No. Okay. So at this moment, if I create a snapshot, I will essentially create for myself a new canvas, right? Which I will be able to use. So if I click snapshot and I'm going to say, okay, you really want to create a new snapshot? Yes. I'm going to say, I'm going to call this tower, so simple tower, design. I can give it a description. I don't want to do right now that, and I'm going to save that. So once I do that, it creates a new canvas. And now I can start designing, right? And I can say, okay, I want to create a building here that's going to be like this, sort of like, oops, I think I accidentally pressed it too fast. It became very short because I accidentally pressed enter too fast. So what I can do is actually I can change the info, and I can change the height of that building to be, let's say, 30 meters high, or maybe 80 meters high because I'm doing the tower, right? I say, okay, what does that look like? I still have the same analysis loaded here. I don't change the sort of like settings, and I can just rerun the analysis here. If I run the analysis, I will see immediately after a while, like the results of that analysis. Yeah. So thanks for the tip, Yosha. So I'll go through the individual design options, but thanks for that. That's a good tip. So you can see, for example, what sort of like happens with the wind comfort, and if like you can see, for example, an edge here that has like more adds more sort of like uncomfortable areas or whatever, and you can say, okay, there's a wake or whatever. Can I just change that? And you can do this iteratively, as we've talked about. So you can say I'm going to use the cool feature that Yosha was talking about. I can pull the face, for example, of that building, and I can move it back in a little bit so that to give more space, right? And I can also pull the top face and sort of like make it a little bit higher, because that's this is just playing around with form at this moment. It's not really you have your final design options and you want to test them. This is exactly at the early stage where you say, okay, what can I do here? And then I'm going to move this, and perhaps I need to also rotate that building a little bit. So I'm just going to like rotate it by like, let's say this much, and then I can run again. I just need to run. I don't need to do much more than just run it again, and then look at the design. Everything I do is saved. So every design change I'm doing is saved. You can of course undo, proceed with caution. Yeah. So again, we have the wind comfort here. I didn't do much better. I probably did a little bit worse because I see a little bit more of that here, and I say, okay, I'm a bit disappointed with all of this. I'm going to create a new snapshot, and I'm just going to call it sort of like 2 towers, right? Because I maybe want to sort of like create, oops, sorry about that, 2 towers, because maybe I have to distribute the mass somehow else. So I'm going to start again, and now I'm going to delete that building, and I'm going to create 2 towers, right? All of these snapshots are there, and I'm just going to create a building over here. I'm probably going to make things worse. I'm not really good at this, but yeah, don't worry about it. And I'm going to create another one over here. Hoping to allow the wind to pass through in this case and like not really be affected or whatever. It doesn't really matter. I can always rotate my sort of like designs, or I can sort of like move them around along the different axes, or using sort of like a gimbal. And yeah, the rest I can also scale them, but I'm not interested in doing that. Of course, you can create roads and other things, but we're not going to talk about that now. And once I've done all of that, I can run again and see if I'm doing any better. So that's sort of like concludes a little bit like, you know, the idea behind InFraReD, how I operate with it. And what I'm going to also show you, hopefully without any big sort of like hiccups, is how you explore the different like snapshots you created. So here, yes, I see I did sort of like create a wake here, but I somehow am better over there. I can look at the percentages again and judge. But if I really want to look at sort of like the individual sort of like design snapshots that I've taken, I can go back to the main menu, and I'm going to load a different project because at this moment I don't have enough snapshots perhaps there. And here we have a few hiccups, but in terms of like the interface, but it's still like it's working quite well. So I'm going to load some other sort of like, of course we have a bunch of like crazy designs here because we've been using this account a lot, but I'm going to load this sort of like Frankfurt study, and then I'm going to show how we can, how we can play around with different snapshots. So, and I'm going to go directly to the exploration tab. And this will take a little bit of time to load, but it's because it has a lot of snapshots.
Yeah, just to comment a bit as we wait for the metrics, there was a few discussions. So yeah, the wind comfort that we see is currently evaluated on a specific wind direction and wind velocity, right? So it's not a yearly directly, but with the integration in Grasshopper, we will show how that can be approximated quite nicely, like yearly studies.
And I'm muted. So here we are looking at our sort of like different snapshots. We have a tree view, which is like how we arrived at every snapshot. So we started from the origin, and then we created like C0, and then that was C1, C2, blah, blah, blah. Or we created B, and then, you know, this is a different tree structure because we started from somewhere and then we started doing snapshots after one after the other. So that's shown here. So we have a history of how you design. But you can also see just everything in an overview. You can hover over and see like a little like snapshot of everything that you've done. And next to this here, we have the parallel coordinates view, which is going back to Thiago's question from the morning. This is where we are actually using the parallel coordinates. This is just one aspect of it. You can see the different sort of like percentages for the wind and the different KPIs essentially. You can also see them in a more like a traditional bar chart where you can also go hover over every one of those options and see where they are. And you can also select a subset. Let's assume that I want to select this sort of like, yes, okay, this subset, and it will show me all the results from those sort of like conditions, from those, yeah, I'm gonna also select, I can also select these individually. Oops. And sorry, one second. I'm going to select a few of them, and you can compare them, right? So here you can see the comparison and how differently they sort of like work in terms of their design. So solar radiation, sunlight hours. I'm not going to go into all the details. You can also, of course, at the end, download a table of all of the results and do more sort of like intricate like analysis with them. Yeah. So that concludes my part. Hopefully I didn't take too much time. Any questions?
Seems cool, the analysis part. Very nice.
I hope it's also understandable, not just cool, because that's something we're trying to avoid.
This is what I mean by cool. Like it has, yeah.
Okay, cool. Anything else?
No, great work, guys. It sounds very nice.
Thanks.
It's also much faster than what you see on Zoom, obviously. The sharing is always a bit with latency. Yeah.
And you know what the best part is? In that email Angelos has sent around, he's handed you guys credentials. You are genuinely one of the first public groups that we've given access to. And you get to play around with it, poke at it, break it. Please be gentle. But that's one of the modes that we'll be offering through the web app. That's one of the ways we'll be doing providing access to these machine learning models. Do I have any other questions before we talk about the second mode, that is through Grasshopper? Okay. Well, I'm going to need you guys to actually dig up that email, get those credentials, and alongside that, open up Rhino and Grasshopper. For the next 20 minutes, I'm going to be taking you through a demo of how to use a library, the InFraReD library, to do all what you just saw within Grasshopper, perhaps something that you're more familiar with than, say, a web app. But of course, both options are available. You haven't received the email yet. Christina, can we double check that those emails went through, Angelos, please and thank you.
I'm sending them as we speak.
Cool. So yeah, we're getting the emails. Could everyone just open up Rhino? Within those emails, you'll also receive a zip file. Within that zip file is the InFraReD library, something we recompiled this morning. So we'll see how that goes. As with all Grasshopper libraries, could you please open your components folder, unzip it, put it inside there, and then do the whole unblock thing. I reckon we can do 2 or 3 minutes before we actually get started here. Now, of course, if you ever find that you're falling behind because you're running over time already, I don't want to prolong this too much, but this is recorded. It's live streamed on YouTube. The recording will be there. If you ever feel a little bit lost, you can always go back to that and watch that again.
Maybe Narit, do we want to show this unblocking and how we drop it in for people that maybe are not very familiar with Grasshopper? Also, if you don't have Grasshopper or never used it, it's fine. You can follow along. It will be informative in a way. Yeah.
As a side note, we had beginner Grasshopper in our prerequisites. Does anyone not have Grasshopper skills here? And that's totally fine, because you have the web app, of course.
I also have to mention that for the second group, I haven't received the emails. They're not there on the Miro board.
Okay, for those who are less familiar with Rhino and Grasshopper, this is Rhino. You can open up Grasshopper by writing in Grasshopper in this command line and clicking enter, or clicking this green Grasshopper icon. Click through all the errors. Okay, dokes. For those who don't know how to find the components folder or have never done this before, you can easily access it once you've opened up Grasshopper. We're going to File, Special Folders, and Components folder. There, a file explorer will open up, and you can drop and drag that zip file that came with the email, once you receive it, straight into that components folder, wherever it's pointing at. It's probably best to create another folder within there called InFraReD or something similar, and then put everything inside the zip inside that InFraReD folder.
All emails have been sent now. So if you haven't received them, yes, you've either didn't add your email or there's something wrong, because I see all the emails sent now. It should, if you refresh, it should be there. The file is only 265 kilobytes, so it shouldn't be taking that long. But yeah, let me know.
Again, all of this will be recorded, so don't feel particularly rushed now. You can always go back and attend it at your own pace. So in the once you've done that, once you've had your InFraReD folder unzipped, put inside the components folder, you'll see this plugin added to your Grasshopper interface. It'll be under I for InFraReD, and within it are 6 subgroups. Because it is a web app, because it is something that exists on a server somewhere out there, we need to authenticate. You've been given your credentials, and you do so by using this first component. I'd like everyone to try and follow me as we go, but of course, no pressure. So this first one here, InFraReD Authenticate. This here is where you would provide your username and password that would come in your email, and this would then give you as a return. It would send out requests to the InFraReD server, and in return, it would give you an authentication token. This stays valid for about an hour, and as long as you keep sending requests, which is essentially happening every time you use one of these components, that token will keep refreshing. There's no need to keep logging back in, re-authenticating, unless you've exited and come back a little bit later. So if you're at this stage, this is your authentication component. Just pull in a couple of panels and plug it up into your U and P for username and password respectively inputs. I'm going to do it off camera because I will be using a different set of credentials.
I just want to say at this moment to everyone, if you haven't received your credentials yet, it's fine. Like, please watch the sort of like the tutorial, and then we will figure it out. I mean, you should all have received it, but like I'm figuring out why, or your firewalls, or perhaps something else. I'm just going to put everything here as a chat. It's all fine.
Now, once you've plugged up your username and password, you'll notice a little message pop up underneath your component if you've logged in successfully. Once you've plugged both up, it would send a request to our servers, and then you should get a logged in as the name of your user. Now, the way we're going to use InFraReD is quite similar to the way it's used in the web app. I mean, it's the same thing, really. It starts off by needing a project. So this project is where you would define things like where in the world it is, how large is your project area, and more importantly, the analyses. So in the web app, you notice that in the context mode, you have to assign, hey, I'd like to add an analysis. It is a wind comfort, and then it takes this specific wind direction and wind speed. This is something that we kind of push to have as static as possible. Decide once at the start of your project so that whenever you make design variants, or what we call snapshots, you can then compare them with the same set of analyses. If you have a lot of different design variants and then a lot of different also design analysis parameters, it's more difficult to then compare. So in this Grasshopper workflow, we actually implore that you, when creating a project, and this comes to be the second bit, InFraReD create project, we have as this bottom input the analyses first. So we're authenticated. Let's do our next step of creating a project. If we pull that out. And this is something that I kind of want to suggest we do always when using these components, and that is starting out with them disabled. These are components that are sending requests to the InFraReD server whenever computation is accepted. So for instance, if we were to start plugging up inputs and some were optional and you weren't exactly done, every time you plug up a new input, you're creating a new project. So I would suggest disabling it first, setting up all your imports, wiring it up, and then enabling it. So let's create some inputs. This is the create project component. And as mandatory inputs, we have the project name. I'd like to call this demo. As a description, I'm just going to call it this project is used to demo InFraReD. SB, site boundary, a rect that represents the bounds of your project area. So you can do so in any way you see fit, whether it be in Rhino or in Grasshopper, whatever you are more comfortable with. So similar to the web app, there is a certain limitation on size. With the machine learning models in the back, they are rather computationally intensive, and the server that it's on is a dinky little CPU server only. I wish you had a GPU server. And so we're going to be restricting the size of your project to 500 by 500 meters. Oh, before we do that, make sure you change your units here, unit settings of Rhino, into meters. Now let's link this site boundary, this project boundary, up into Grasshopper using the rect container and the set one rectangle here. Dang, I have to redo it. With the rectangle in Grasshopper, you can plug that up. Now, long and lat, these are optional parameters and they default to null island. However, I would like to add in the long and lat of Vienna, as that's what the solar radiation and sunlight hour models were trained upon. They will only work in Vienna. And finally, as said before, your analyses. So your analyses actually come from a different group up in this InFraReD plugin here. And we've provided the ability to do the same as on the web app. To save computation, I'm just going to choose a couple, that being, say, wind comfort and wind speed. The most visually interesting anyway. Now, these in themselves have a lot of input parameters, such as your wind speed and wind direction, as seen on the web app, but also visualization and filters. Now, we say this many times, this is something that is currently in the works, it's under active development, and we've planned to allow for the inputs where users can choose how their data will be visualized, what kind of filters will be used on the data. For now, these are not functioning, they won't do anything, but for the future, they're there. Merging these two analyses together, plugging that up into your analyses settings input. And we've now successfully decided what our inputs will be for this project. Again, I'd like to say that please make sure that you've got all of your analyses sorted. In the current Grasshopper workflow, you can't actually change the analyses once you've created a project. So let's say down the line, once you were working on this task for DigitalFutures, that you would decide to change your analyses. What that would require of you is to create your project again. Okay, enabling this component, sending a request to the server, and yep, back once it's successfully ran, your project's created. Now, this is a bit counterintuitive in terms of how you would generally use Grasshopper, but is a symptom of the fact that we are interfacing with a web server. Once created, once ran successfully, I'm actually going to disable it again. And from now on, whenever I want to deal with my project, I'm actually going to use the load project instead. You can load a project by name. That I've called demo. I'm actually going to add some scribbles so we can keep track of what's going on here. So to create project. This is one authenticate. And then loading a project here. So when a project is created, what's there's another difference between using this here and then using the web app. When a project is created, a blank project is created using Grasshopper. If you're on the web app, what actually comes with is the context, so the pre-existing buildings, and that's obtained by OSM data. Here, you don't have that, so you kind of got to provide it yourself. As it stands, there are currently no snapshots. So let's prepare a snapshot, our first design variant, using this sync snapshot component. As always, I'm going to disable this. So first up, again, name. What's the name of our snapshot? We're similarly going to call it, follow the logic of this being a design variant. And let's say for this toy example that this is the status quo. A short description. I don't know. This is what's there. Please be more expressive with the description. Yep.
Comment to use bifocals component to see the names of components you're using.
Okay, talk to me. How do you turn on bifocals?
Display, I guess.
Display?
Yeah.
Full names.
Full names.
Yeah.
Is that what we're talking about? Got it, cool. Yep. Oh, it's less pretty, guys. It's less pretty. And yeah, cool.
And also, I think if you can enable the name, if you go to display again,
yeah.
Sorry, you can unclick the draw icons. Yeah.
Come on, team. Let's use icons. Anywho, yep, cool, that's fine. Next is the root snapshot. So, when a blank project is created, a blank snapshot is similarly created. And this is a technological workaround as it stands. It would be more elegant if there was no snapshot when you create one, but this is how it is. By default, a root snapshot, okay, by default, when you create a project, a snapshot, a blank snapshot called origin is created. Now, whenever you're making new snapshots, whether you're creating new ones or syncing your geometry, your streets, your buildings into a snapshot you've created, one of the required arguments is this root snapshot, otherwise known as your previous snapshot. So in the demo that Angelos was giving about the web app, you saw this tree view of your snapshots where you have at the top your root snapshot, and then this chain of essentially a tree-like structure where each branch is variations, iterations on design variants. And this is kind of what's happening here, where you can say when you create a new snapshot, you can specify what's the name of your root snapshot or the previous snapshot. So you can keep track of what branch your iterations are on. As with any snapshot that's not the first one, your root snapshot will be coming from origin. If you're not caring too much about this, you can just always set it as origin, and then you'll have this very wide but shallow tree. That's really not an issue. It's more for organization. Next are your geometries. So currently we have as analyses solar radiation, sunlight hours, wind comfort, and wind analyses, and wind comfort and wind speed. And each of these analyses, as it stands, are only predicated on the geometry of the buildings, the volumes of the buildings. So when syncing your snapshots, streets and points of interest, although useful for other types of analyses, are not yet ready to inform any analyses that we're providing with this current version. So really all you need to provide here are the buildings. So these buildings need to follow a specific format. If you mouse over this input, it says supply InFraReD buildings here from the InFraReD create buildings components. When building this plugin, we've done our best to kind of add descriptions about what are your inputs and what are your outputs really doing. So if you're ever confused, mouse over them. It should tell you there. So from the InFraReD create buildings component, that there is now in group 3. So these are parsers. Again, another technical solution that allows us to translate Rhino and Grasshopper geometry into something that InFraReD can understand. So using the InFraReD create buildings component, we need to provide it a set of building geometries, a list of meshes representing buildings. And alongside that, the use. This, again, no current use in InFraReD now, so let's just provide them the building volumes. And it takes meshes, so watch out for actual geometry types. So if you're following along, let's just make a random small toy example of the site here. I'm just going to do a few buildings. That'll do. And with that, they are currently BREPs. And remember that this input here takes meshes. So we're going to assign all these BREPs into here and then use the mesh BREP component. You mentioned the limitations, but is 500 square the only site boundary shape that can be accepted? So in terms of a shape, squares and rectangles are accepted. The 500 by 500 limitation is your optimal choice to get the largest area possible, to include as much of your context into the analysis as possible without destroying the server. You can obviously do like a 300 by 500 if you have a particularly long rectangular site. But again, you're missing out on that extra 200 by 300, 200 by 500 meters. So it's almost like a why not do a 500 by 500. Okay, we've got our BREPs, we're converting them into meshes, and then we're turning these meshes into the buildings here. This is the parsing of geometry into something that InFraReD can understand now. Again, streets POIs aren't necessary. You can leave them blank. And finally, site boundary originally represents the bounds of your project area. Now, when you load a project, which really only needs your project name, it also comes with your site boundary. That's kind of what's stored as well. So let's use that. Always mesh, I can't use poly surface. Yeah, that's an interesting point. So really, when geometry is represented in InFraReD, it's represented actually with a footprint and a height. You can't get any more complex than that as of right now. So when we do this kind of, it needs to be a mesh, it was kind of a catch-all situation where we want to say, okay, any geometry considered out there, as complex as it is, we want it to be a mesh so that we can run an operation, so that we can assure that we can get to this footprint and a height. But in actuality, it's a lot more simple than that. So to answer your question of always mesh, can't I use polysurface? No, you cannot use polysurface. You'll need to mesh that first right now. In the future, perhaps. So finally, let's sync our snapshot. So you might say like, okay, how do you know if this is successful? But if you've used Grasshopper before, you'll know the orange and the dreaded red bubbles. We've also done our best to provide verbose error messages. If you are doing this and playing around yourself and you're not sure if things went through correctly, as long as there's no red bubble, you're fine. That worked and it's on the server and it's ready to go. If you do see a red bubble, mouse over it and read the error message. Again, that will often tell you what the issue might be. So we're at a point where our snapshot, our lovely little street here, our little toy example, is represented in InFraReD. So we can now run our analyses. Of course, if you ever want to say change the position of these buildings, let's say I want to move this over here, this then triggers this BREP container to update, triggering this whole computation, meaning that this ran, meaning that this change in geometry now exists up in the server. But that's also a downside. Every time if you make a change here, you're firing off this component and it's sending a request. And in larger cases, that's a rather large request. So Again, if you have a lot of changes and you don't really want to make it a snapshot yet, just set this to be disabled, make your changes, and then re-enable it when you want to fire the request to the server. Let's be diligent coders. This here is syncing snapshots. Was that 4? It was. Okay, so once we've created our project, once we've created some geometries and sync that up to the server, we can now run the analysis on them. Remember that the analyses were set up all the way back here. Oh, they're so chunky. And now you're in the final group here. That is run and read analyses. The only requirement to run the analyses is a name, and it's a name of your snapshot. That's defined here. Remember, this is a live connection, so every time you update your geometry, it updates the server if you set it that way. So the current geometry in the server is this, which is attached to simply this name of your snapshot. As long as you provide this information into this run analysis component, the server knows exactly what snapshot and thus what geometry to run the analyses on. Let's plug it up. Let's stare at server logs until it's ready. And now it's done. Now, I can't stress this enough. This used to be something that would take 5 hours to do, and yet we get it within 5 seconds. We got 2 in 5 seconds. Anywho, so these are analyses. These are what's coming back. Let's also document that. Do I have any questions? Feel free to throw it in the chat. Feel free to chime in and talk to me.
I have a small question.
Yeah.
Because so many people will be working on it, what happens in the server if somehow people name 2 geometries like the same way? For example, so will we get an error or?
So that's a great question. Of course, with collaborative tools, there's always that question of, well, how is that handled? And there's a lot of technical nuance where I can say, okay, in this specific case, this is what happens. However, what's the fun in that? You guys have the credentials, you guys have the web apps, you guys can talk to each other and play around with this. You tell us what happens.
Good.
I'm sorry if it's an unsatisfying answer, but I think you'll have more fun with that way.
Okay.
Okay, you have your analyses results. And now we can't, okay, one more thing, and that is to read the analysis. Oh no, wait, we need to explode first, question mark, bang. Explode tree, sure. So when you use this run analyses component, what comes back is, in Python language, a dictionary that contains all the different analyses based on what you've set it up for at the project level. So there are 2 analysis results coming back here. We'd first need to throw it through an explode tree component so that we can access each of those different analyses separately. Taking one of these, we can say, oh, Yosh, we don't see the icon change. So we can take one of these analyses, plug it through this, the InFraReD analysis components, and then you get a bunch of different data back. This raw data is the one kind of we care about, the spectacular thing. And using any sort of visualization library, such as Aviary, you can see what comes out, say an image viewer. What you're seeing here is our first analysis, that being wind comfort. Taking the geometry we have in Grasshopper, running the analyses through the machine learning models, and sending that back here. These black and white, this gradient you see here, coming from return values existing between 0 and 1, then normalized values coming out of it. And in a later workshop, Joshua will be talking to you guys about how to take these values, interpret it, and understand it. How about we can visualize it on this rectangle here? We got to do something a bit cheeky here, and that is to use a Grasshopper script component where we take an input and just pull out a specific key value pair from this dictionary here. If you didn't see that, that was A equals X, open square bracket, B64. So this little GH Python component is necessary because what comes out of here in the Grasshopper world is really just interpreted as an Iron Python runtime Python dictionary. You can't interrogate this any further without using another GH Python script component. So at this stage, what actually comes out of this is a base 64 image. You can see here it's a really long string. And so focus on Grasshopper files, by the way, if you haven't already, precisely. Yeah, so you'll be provided this if needs be. Don't worry too much. There's another lovely component called deserialize image from string. And this actually comes from human? Yes, human, I believe. And it takes this output here, string, a human, a base 64 image encoded as a string, encoded as base 64, and it then saves the image to a temporary file on your drive. From there, you can open it back up and just show that image on a surface. So it would be, I don't know, import image, I think it is. Yeah. So we have the file, we have our rectangle. Let's plug that up to our site boundary here. And we have this annoying error of Y flipping. So let's take our rectangle, flip it around real quick, and then we can see really the data as it should be. So what this is a deconstruction of a rectangle, a flip along a plane, taking the Y, making it negative, and then forming that rectangle back up. And then we have our analyses rendered on the project site. And that's essentially all I have to show you guys. Do you have any questions here? You can switch between your analyses and render different ones. This is your Win Comfort.
I have a big upload.
Heck yeah.
for doing this. This looks fantastic. Yeah.
Angelos hasn't seen this until just then, so. All right, we've gone on long enough. I don't see any questions, although if you do have them, feel free to throw them in the chat, feel free to chime in, or feel free to email us. You'll have your authentication and the InFraReD plugin provided to you in that email. If you haven't received that email by now, that's a cause for alarm. So now in the chat, feel free to say, hey, I didn't get the email, please send it to me again.
We had a lot of issues with spam folders, with QCL, like blocking our files, etc. It's very possible that your files have been blocked or whatever. If you have an issue, send me an email saying I haven't received the files and which group you are in. So send an email to me at this specific email address. I will send it to you. And tell me that you have not received your file, and you need to tell me which group you are in, right? And yeah, that's it. Okay.
I have just a quick question. For the authentication component, we need another component, or it should be functioning like just with that component and the login and password. It should be okay.
Yes. The latter of those two. That authentication component simply takes those two inputs. Once it receives those two inputs, it then does some magic in the back saying, yes, this Grasshopper document is good to make requests in InFraReD.
Okay, it's just because mine is still, it's red for some reason, but I will figure it out.
Spend 10 to 15 minutes trying to figure it out. But if you spend any more longer than that, reach out and be as descriptive as possible in what the area is. Actually, general comment. If you are ever using InFraReD as the web app or InFraReD through Grasshopper, and you run into an error, spend some time trying to debug it. We've provided enough info to kind of figure it out on your own. But no, don't bang your head against it for too long. If you spend more than 15 minutes or so, trying to debug it, it could be that there is a bug on our side, and it's something that we perhaps need to fix. Again, it is under active development. So at that point, screenshot a bunch, write down exactly what the error is, and just maybe send an email to me and we'll look right into it. I'll throw my email in this chat if you haven't already.
Yeah, we also created a Slack. I'm going to share it now, which might be easier at some point. This is the link. It would be great if everybody of you joins. I think this makes communication much easier. And we can share, we collect error messages and issues and can discuss solutions together.
Yeah,
exactly. I'm going to send that to an email with an email to everyone, so that you can join us. Yeah.
We'll also create a channel for each group, so you can kind of organize yourselves there as well.
Joshua, did you paste the Slack on the chat?
Yeah.
Can you do it again?
Ah, okay. It was private. Sorry.
Who are you chatting with?
No idea. Who's InFraReD?
Okay, dokes. So yes, you have your project description. We've shown you a couple of different ways to interface with InFraReD. We have a Slack now. If you ever run into any issues, you know what to do.
And tomorrow we will look at it again and integrate it further with other Grasshopper-related workflows. So, yeah.
Okay, I'm just sending this Slack link to your emails. If you still have problems receiving that, please let me know. I just sent it to you. We also have it on the chat. You should be able to get on Slack. It will be the easiest for us to sort of like join Slack and be able to sort of like communicate much more sort of like reactively there. Yeah. Thank you a lot for your patience. We did go 1 hour over, but it's probably what we expected. Hopefully from tomorrow onwards, this is not going to happen anymore. And we're going to be like right on time. Homework. Yeah. Very importantly, what you need to do for tomorrow with your groups is you need to meet with your groups. So just find a way to communicate. We will create the Slack and the Slack channels. So use the Slack channels. We're going to create them in a bit, and then you'll be able to join these channels with your group mates. And the important thing is that you need to review the site. You need to look at the site, understand your problem, set a problem statement, be ready to sort of like address a specific problem and figure out what analysis you might be needing. A very, very important topic here. Like we can't, so we are doing groups because we can't really attend to 30 people, 35 people sort of like individually. So this is not really important. Like just the problem definition, the problem setup, like each of you have different sort of like research interests. It doesn't really matter. Just find something that's a good case study for you to investigate, and don't sort of like spend too much time sort of like trying to figure out, you know, between you, you know, what is the best sort of like research little project. This is just an example. It's just a small case study. Just devise something easy, meet with each other, and get ready for tomorrow. Because tomorrow we will be able to start directly with the group work, and each of you will create breakout rooms, and we will go with each one of you through the project that you're going to set up, and we will start already setting up the analysis. So there's no time to waste. Yeah.
Yeah, we also like had this little template that might help you to define a problem that you can actually use performance analysis with. It's on Miro. I will link it in Slack again. So this might help you kind of to facilitate the process of finding a project. You can also just use something maybe you worked on before, and now you would like to use some more analytical parts in it. Yeah. And tomorrow we will show a few more models and so on you might add there and integrate as well. No.
Okay. Any more questions?
Can we also add a group? Sorry. Can we also add group numbers within Miro? So moving forward, there's no 100%. Confusion?
Yes. So I'm going to add the group numbers right now so that we all have them there. Okay. What else? And I'm going to create a little space for each one of you on Miro. so that you can sort of like use it to define your problem. I would say please use the Miro board heavily. It's really great. So it helps us understand a little bit better what you're onto. So I'm going to call this group 1, and then it's group 2, etc. Yeah. Okay. Other questions?
Okay then.
Just quickly from the chat, Jay, the .grasshopper file I don't think has sent unless you're referring to the zip file along with the credentials. Is that what you're referring to, or are you talking about the Grasshopper file I just showed?
Hey, I'm talking about both of them. I haven't received any email yet.
Okay.
For some reason, but thank you.
Sort that out.
Okay, so see you tomorrow then.
Thanks, guys. Good luck.
All right. Thank you.
Also in the Slack, of course. So
thank you very much.